All right, good afternoon or evening, AP Calculus students. So this is my video for today's homework. If you're watching this beginning, that's great. So I'm going to summarize what I'm going to try to do in this video. So first, this assignment is a bit lengthier. It's been a while since we've done Delta Math. So to reflect some of the work that I want us to get back on track on, it's going to be a decent amount of problems. So first thing is we are going to look at L'Hopital's rule, which is the rule we did today, right? Then I'm probably going to do one of each of these rest of the problems. Oops, what did I do with that? All right. One of each of the rest of the problems. However, with the L'Hopital's rule, the first one, I'm going to do multiple of these because they have different forms. So let's get started with that. L'Hopital's rule. I'm going to skip to first the most straightforward form, which is something like this, right? They give a straight up limit. There's no confusing graphs, all that sort of stuff. Although you'll see they aren't too confusing. So first, let's apply this. Let's apply the rule we learned today. So if you remember our rule, it's basically if the limit as x approaches some number, f of x over g of x, if it's equal to 0 over 0 or infinity over infinity, then my limit can be solved as f of x divided by g of x. But what I do is I take the derivative of each of these. So f prime of x over g of x. All right. So this is my L'Hopital's rule. Now, let's see if, first thing is, let's see if I can actually use this rule for this problem. And how do I know if I can use L'Hopital's rule? Well, again, it has to be equal to 0 over 0 or infinity over infinity. So I'm going to plug that into Desmos. 4ln of 2 times 0 plus 7 divided by 3 cosine of 2 times 0 plus 6 plus 0. Cool. So, whoa. Oh, sorry. This is not 0. I'm plugging in -3 for x. I don't know why I plugged in 0. -3 for x. -3. Right. Okay, undefined. So it looks like it's going to be 0 over 0. Here, let me actually show this step by step. The numerator is 0. The denominator is 0. Cool. So what does this tell me? This tells me I can, emphasis on can, use L'Hopital's rule. Right, so we're good. So I can continue, right? If I couldn't, you would just click DNE and that would be your final answer. However, in this case, I can use L'Hopital's rule. So let's do the rule, right? So the rule is I'm going to take the limit as x is approaching -3. And I'm going to take the derivative of the numerator, derivative of the denominator. Well, what's the derivative for ln of 2x plus 7? So I don't want to show, this is why us being good with derivative rules is so important, because I don't want to show all the steps for this, but this is a chain rule, right? So what I'm doing is take the derivative of the outside. The outside is the natural log, right? So the outside is going to be 4 over whatever's on the inside, right? That's just our rule for the derivative of natural log. So actually, I'll take it a bit slow just to clarify. Remember, our derivative of natural log is 1 over x, right? So 1 over whatever's on the inside. Well, in this case, there's a 4, so I multiply the top by 4. And then the inside is 2x plus 7. Remember, I leave the inside the exact same. All right, so this is my derivative of the outside. Then I multiply by the derivative of the inside. Derivative of the inside, my inside function is 2x plus 7. I'm going to take the derivative of the inside, so I multiply by 2. Cool. That's the derivative of the top. Derivative of the bottom, same idea. This requires a chain rule. Derivative of 3 cosine. Okay, why is this not highlighting? Derivative of 3 cosine of 2x plus 6. The outside is 3 cosine, right? So the derivative of the outside is going to be -3 sine, right? -3 sine. And remember, I leave the inside the same, so it's 2x plus 6. Then I multiply by the derivative of the inside. The inside function is 2x plus 6, so I multiply by 2. Then I plus the derivative of x is 1, right? 1. Cool. So I could simplify this. 2 times -3, that's -6. So I can simplify that, I guess. But here's going to be my final answer. I did L'Hopital's rule by taking the derivative. I did f prime, and then I did g prime. So I have the derivative of the top and the bottom. And now I just got to plug in -3. So let's do that. 4 divided by 2 times -3 plus 7 times 2. All right, -6 sine of 2 times -3 plus 6 plus 1. Let me change this to radians. Okay, so my answer is 8, right? Yeah, you could definitely manually do this yourself, but once I replug it in, I notice I'm not going to get 0 over 0 anymore. I get 8. So let's see, 8. Submit answer. Excellent, 8. Cool. Let's try a different sort of problem. Cool, they have ones with a graph. Let's take a look at the graph ones. So first, this is my L'Hopital's rule. Remember, I need to get 0 over 0 or infinity over infinity. Let's see if I get that, because if I do, then I can use L'Hopital's rule. So when I plug in 1, it's going to be 2f of 3 times 1 minus 1 squared. That's my numerator. The denominator is 1 minus 1 squared, and I know the denominator is 0. Okay, so it just matters that this part is 0. Well, this is 2 times f of 3 minus 1 squared, or minus 1, I guess. And f of 3 is what? Well, let's look. I go to my function, because it tells me my function is f. I go to f, I look at 3, and 3 is -1. F of 3 is -1, so it's 2 times -1 minus 1. All right, 2 times -1 minus 1. That looks like it's equal to -3 to me. So I actually think I cannot use L'Hopital's rule. I cannot use L'Hopital's rule in this case. Cannot. So my answer should be DNE. Let's see if that works with this one. Cool, it's DNE. Let's try to do another one where I can use L'Hopital's rule. Here, let me pause really quick just to make sure I can do it with this. All right, yeah, let's look at this one because from what I can tell, I can use L'Hopital's rule. Let's see, my numerator would be 2 minus 2 times 1, which is 0. So my numerator is 0. My denominator is f of 3 times 0 minus, I'm sorry, 3 times 1 minus 1 squared, which is equal to f of 3 minus 1. And let's look at f of 3. F of 3 is 1. So it's 1 minus 1, which is equal to 0. Right? Excellent. So my numerator is 0, my denominator is 0, so I can use L'Hopital's rule. Emphasis, I can do that. All right, so let's apply the rule. The numerator, derivative of 2 minus 2x, that's just going to be -2. Derivative of f of 3 of x. Well, this is a chain rule, right? My outside function is f, so the derivative of the outside is just f prime, and I leave the inside the same. So f prime of 3x. Right? Now I multiply by the derivative of the inside. The derivative of the inside, derivative of 3x is just 3. 3. Cool. Then minus derivative of x squared is 2x. All right. So let's actually just solve that then. So it's -2 divided by f prime of 3 times 1 times 3 minus 2. Oops, I'll put this negative right there. All right. So that's -2 divided by, I'll simplify it as 3 f prime of 3 minus 2. And now the question is, what is f prime of 3? What is f prime of 3? Right? How do I know that? They don't give me a function. I don't know what f prime of 3 is. Well, remember, f prime of 3 is equal to the slope of f at 3. So that's what I'm looking at here. Right? I go to my function, I go to 3, and the slope of the function here is +1. You can see where my mouse is pointing to, right? The slope of the function at 3, it is increasing, it's going up by 1. So really, f prime of 3, that's just 1. So it's negative 2 divided by 3 times 1 minus 2. Let me just copy and paste that. Boom. My answer is negative 2. All right. So hopefully that makes sense. Really the main takeaway here is that sort of when you're looking for f prime of 3, to look for the slope at 3. That's the main thing. All right, let's try one more problem, which is the table problems. Okay, here's a table problem. First, let's check to see if I can use L'Hopital's rule, right? Can I use L'Hopital's? Let me erase some of my work. Okay, can I use L'Hopital's? Well, to test that, I'm going to plug 1 into my function, so it's going to be f of 1 minus 2 times 1 over 3 times 1 squared minus 3 times 1. All right, let's actually solve this. F of 1, I go to 1, I go to f, so it's 2 minus 2. All right, actually, here, I'll write these out separately. So f of 1 minus 2 times 1, this is equal to 2 minus 2, which is equal to 0. So my numerator is 0. Now let's look at my denominator. 3 times 1 squared, that's 3, minus 3 times 1, so 3 minus 3, that's equal to 0. Cool, it's 0 over 0. I can use L'Hopital's rule. So we're good. I can use this. So let's move on. Let's take my limit. My limit is as x approaches 1, the derivative of the top and the bottom, right? Derivative of f of x is just f prime of x. Derivative of 2x is minus 2. Derivative of the denominator, that, I think you all know that, it's 6x minus 3. Cool. So I'm going to plug in 1, so it's going to be f prime of 1, here I'll write equals f prime of 1 minus 2, all over 6 times 1 minus 3. Excellent. And this one, we use a table. Unlike the last problem where I look at the slope of the line, here for f prime of 1, I'm given a table. F prime of 1 is 3. So it's equal to 3 minus 2, all over 6 minus 3. That simplifies to 0.3 or 1/3. All right, so 1/3. All right, so those are the 3 types of L'Hopital problems you're going to see on here. I would recommend, if you have any questions, replay the video, carefully look at my Desmo steps. Hopefully you can make sense of them. I'm going to go back now, and I am going to go through some of these problems. Okay, first, limits graphically. Okay, let's see. They asked me for the limit as x approaches 0 from the left. So x is 0 is right here. Hopefully y'all can see my mouse. I have a hard time showing or knowing how else I would show these problems. So x equals 0 is right here. As I approach from the left, coming from the left, I'm approaching a y value of negative 6. Remember, the limit is all about, actually, I'm going to write it out here. What y value am I approaching? What y value am I approaching? Right. So, negative 6. Approaching 0 from the right, I'm also approaching negative 6. From the left and the right, my limits are equal to each other. So my overall limit is going to be negative 6. When I go to f of 0, so this is not the limit, I'm not approaching anything. I just jump to 0 and I see an empty circle. So I know this is DNE, or actually undefined, whatever way. I think Delta Math takes either answer. All right. Cool. That's one of these problems. And you can see they draw it. As I approach from the left, you can see I'm approaching negative 6. All right. Cool. It's one of these problems. Let's go to limits from a table. All right. Here they're asking me to approach negative 2 from the left, but I need to use a table. So I'm going to choose numbers that are to the left of negative 2, and I'll getting closer to negative 2. So to the left, let's try negative 2.1. All right. Let's try negative then 2.01. Negative 2.001. 0.0001. And you can see what y value am I getting closer to? I'm clearly getting closer to 0.99 repeating. I'm getting closer to 1. Cool. So from the left, I'm getting closer to 1. Let's try from the right now. To the right of -2 is like -1.9. Okay, -1.99. Let's keep on plugging. Okay, 1.5, 1.05, 1.0005, etc. I'm clearly also getting closer to 1. If both sides of my limits are equal, that means my overall limit is also going to be 1. Right, the overall limit is also going to be 1. Let's try f of -2. Here, I'm going to clear my table again. I'm not plugging in values close to -2. I'm literally just going to straight up plug in -2, and it's undefined. So I plug in undefined. There we go. Cool. That's how we do these problems. Right. Limits of rational functions. I'm going to do one standard one. Let's see. All right. Okay. Yeah. Cool. So limits of rational functions. Here's how I would approach this problem if I didn't already know what to do, right? So first I would plug in -7. So it's -7 squared minus 1 all over -7 squared plus 6 times -7 minus 7. So when I plug it in, I'm going to get a divide by 0 answer. Divided by 0. Right? And you might be asking, can I do L'Hopital's for this? Well, not quite, because this top part simplifies to 48, so I can't do L'Hopital's rule, right? So what other things can I do? So I'm going to say direct substitution gives me a divide by 0 error, right? So I can't do direct substitution. Let's move onwards then. If I can't do direct substitution, I'm going to go to what method? I'm going to try to factor, cancel, and simplify. Hopefully this rings a bell. Factor, cancel, simplify. Let's try to do that. So I'm going to factor this. The top factors 2, x plus 1, x minus 1. Denominator factors 2, x plus 7, x minus 1. Excellent. Yeah, I'm just going to continue actually. So this simplifies to, well, the x minus 1s cancel out, right? These cancel out. So what I'm left with is just x plus 1, x plus 7, right? All right. X plus 1 over x plus 7. Then I'm going to see if I can plug in -7 for x. So it's going to be -7 plus 1 over -7 plus 7. And if you notice here, actually, my denominator here, -7 plus 7, that's 0. So I didn't actually solve anything. Sort of weird. Ideally, you would get an actual answer here. So this is still does not exist. So you would write DNE. Ideally, though, I wish I chose a different problem, but ideally you would have an actual number for this. But if you still get to divide by 0, it's DNE. It goes into your vertical asymptote stuff where you have to plug in values close to -7, all that sort of stuff. But for the intents of this problem, it is DNE. And okay, I do not know why the answer is not submitting, but let's try show solution. Okay, 1 second. All right, I do not know why that glitched out, but okay, it's showing me it. There we go. Show solution. My answer is DNE. Okay, cool. But that would be the steps, right? You direct substitute, and it's probably not going to work, so you're going to have to factor, cancel, and simplify, and submit whatever answer you have there. All right, limits of piecewise functions. Let's do that one now. All right, determine the limit as x approaches -4 from the right. So if I'm approaching from the right, you have to determine which one of these functions am I going to use. Am I going to use the function for when x is less than -4, or when x is greater than -4, right? Well, if I'm approaching from the right, I'm going to use a function for when x is greater than -4. So it's going to be 10 minus x squared. AKA, it's 10 minus -4 squared, because I plug in -4 for x. This simplifies to -6. So I just plug in -6. That's it. I just have to choose the right function. All right. I'm going to do this one really quickly. You could have another example when it asks for limit as x approaches 3, or and it doesn't say left or right, remember, if it doesn't specify left or right, you assume it's from both directions. All right. Okay, so hopefully that makes sense. I'm going to plug in 3, that means into both these functions. So from the left, x is less than 3, it's going to be that function, -1 plus 3, so it's 2. From the right, it's -3 squared plus 4, so it's -4. If they're not equal to each other, well, what does that mean? The 2 functions are not equal to each other. If they're not equal, that means the limit overall does not exist. Cool. Okay, limits to infinity. Limits to infinity. This is my strategy for limits to infinity. Step 1, circle the most dominant terms in the numerator and denominator, right? So let's circle the most dominant terms, or actually I'll write out the steps. Compare the terms and evaluate, right? We're going to compare the terms after and evaluate. Right, so if it's f of x over g of x, actually, how do I write this? If the numerator, or if the top is greater, the function goes to infinity. If the denominator, if the bottom is greater, the function goes to 0. Right, and also remember, if there's a negative and it goes to infinity, your answer is negative infinity. All right, okay. Kind of a lot to write, but hopefully that makes sense. So let's compare the terms in the top and the bottom. The top greatest term is 9x cubed, but it's also being multiplied by 6x. So this is why it's confusing. So the top greatest term is actually 54x to the 4th power, right? That's the greatest term. X cubed times x is x to the 4th. In the denominator, it's 3x cubed times 9x. So that's 27x to the 3rd power. Or sorry, 4th power. My bad. All right, because it's 3x cubed times 9x. So I actually didn't even go over if the top and bottom are equally powerful, just cancel what you can, basically. So 54x to the 4th and 27x to the 4th. This x to the 4th, you can cancel them out. So it's 54 divided by 27, which actually just simplifies to 2. So my limit is 2. All right. Cool. And then they actually tell you if the limit is infinite, state that the limit does not exist. So you actually don't even need to write infinity. You just say it doesn't exist. Let me choose one where that's actually the right answer, so I can show that. Not this one. Okay, this one, the top term is 7x to the 4th. The bottom term is 8x to the 5th. Since the bottom term is more dominant, this one would go to 0. All right. Also 0. Oh. All right, well, okay, fine, an example. So the most dominant term in the top here is 12x to the 4th. The most dominant term in the bottom is 3x squared. Right, x to the 4th is clearly more dominant, right? It's more powerful than x squared. So this goes to infinity, right? And it's positive 12x squared and positive 3x squared. So it is positive infinity. That means for this one, I would put DNE. Okay, hopefully that was helpful. Again, you may not get this the first time, even though it's review. So cycle back to take a look.